So in today's session, we will see what is needed to run code inside HPC. So it's basically hypercomputer. So it's server where you have like big amount of GPU and CPU, and most of the time you run your code with a safe container, either Docker or Singularity, and those basically contain a lot of resources, CPU, memory, and GPU. And today I will present the stack that is mainly Docker, which is a very small part of it, Singularity, also called AppTenor today, and Slurm, which is basically all the jobs and every script that will be run inside the HPC is controlled and monitored. And yeah, so the goal of the session is be able to learn all of this, so core concept of high performance computing, or to transfer and manage your code. So for example, you have your code in your local machine, and what is the typical workflow to take your code and put it in the cluster. So, or we do that, and or we do that with data, or we do that with code. It's pretty much similar, but yeah, I will show you this. Or do we containerize our local environment? So let's say we develop a code in Python with Anaconda, or I don't know, some virtual environment. Or do we take this and put this inside a Singularity image in order to be able to run the code inside the cluster? So we will see this, and once we have like the code in the cluster, the image prepared, we can now work on the cluster, and to work on the cluster, we need Slurm, and I will basically show you the basic command line and what you need to know about Slurm, and let's say the most typical recipe, and this will be present in the Git that I will show you a couple of seconds. Okay. Yeah, and obviously one of the benefits of like HPC environment is that it makes resources much more manageable, it makes the code more reproducible, and it's very efficient. Why most of the time when you will see HPC, you will not see people running Docker images, because Docker do not have like a very good do not handle GPU in a correct way, and Singularity is very efficient with GPU computing. So that's why most of the time when you will see HPC, you will heard and will, people will talk about Singularity and not Docker. And yeah, so it's very efficient, and it can like handle thousands and thousands of users at the same time and schedule the jobs without any flows. So Slurm is very, very powerful. So yeah, can you raise your hand, everyone that do have access, legitimate access to the Latin cluster?
Est-ce que tu peux te connecter au cluster?
So maybe we'll change the question. Which one of you did not try to connect to the Latin cluster? Okay, so first row.
I stopped at the part of the authentication. We needed to go to the PO, and then we got to it. Yes.
Okay, but some of you do have access.
Yeah.
So maybe check with like the guy that have access to like see the exact procedure. But yeah, something useful is being able to have access to your environment, and since I will be using mine just to show you, but the command line should be pretty much the same, and your like IP address and the password should be communicated by Jean-François. So now we'll switch to my PC inside the room, in the other side, my Linux PC. If I hope I do not forget the password. Lourd. Donc, so I did create a small Git with all the content that I will be using today inside this workshop. So it's at this link. If you cannot just git clone this inside the slides, maybe I will share the slide now. So yeah, so basically it should be the next slide. So yeah, obviously there is something that I didn't mention is you need to be some kind of proficient with Linux, because most of things that are inside the cluster are with Linux machine. So there is all devices that are present in the cluster are based on Linux, and if every images that you will download will be in Linux. So every command that will be executed is in Linux. So obviously, as you're already working maybe with Linux or different kind of version, maybe Ubuntu or something else, you need to know some basic command like to be able to work with files and so on. And this one, so yeah, if you have your PC, can you git clone this? And what I will do now is just will send the slide by email, and it will be easier. Excellent. So yeah, as I mentioned earlier, we need to first develop our code in our workstation, and then the first step is how do we transfer this code to the cluster, and this is using some copy protocol, and one of the most popular is SCP and async, and basically once you will be using the GitHub, and inside there is basically some pipeline that show you how you can copy the code, and now we demonstrating you how you copy your code to the cluster with basically you have Python code and you have some data. How do we do this basically? or do we from code inside our PC, or do we put it inside our space inside the cluster? So basically, it will involve this, but obviously those will change depending on your IP address. So now let's go to the live session about this. Okay, look. So once you clone the repo, you will have access to basically this structure of the code. And now what we'll be doing is the first step. So basically, once you have your code and your data is ready, you have to copy the code inside the cluster. And so those SSH batch file will basically do this purpose. So I made one SSH code for SSH script for each purpose. So copy the code, copy the data, and copy your singularity image that we will create later. And basically, this is a good practice. So you want to split your SSH script inside your code with one usage for each. So I want to copy the code, I want to be able to copy the data, and I want to be able to copy the singularity image. So first, to copy the code, basically what you do is you inside this you change and you put your the path of your code. So typically in this example it will be the current path. So for me it will be home Juven code HPC workshop. So I just copy this, but in your case it can be anything, anywhere. And then what you do is then copy, paste. This is basically the name and the IP address that Geoffroy gave you. In my case, it's rziglash arrobas 195.83.246.85. It should be pretty much similar, yours. And then what I do is basically I'm getting where I want the file to be based. And this is an ignoc file that we will talk about later, but basically now if I show you, this will be done. So first let's connect to the cluster. Yeah, so I connect with SSH, sorry, and then what I do, I just fill my password, and I'm connected inside the cluster. Inside the cluster, to see where am I, just wwd to see exactly where am I, and when I'm connected, I am in data GPU rziglash. That's basically where am I, and I want to just paste this code inside. And basically, if you see the structure of my code with ls, my repo are like this, and if I want, for example, to create another repo and see, let's say I want to copy this inside code, I just need to have this created like this, just to copy this inside code. And for just like the purpose of this presentation, I will just copy in the root of my access inside the cluster.
One quick question. Does the home folder needs to be data GPU? Like
Yeah, it should be the same.
But
you-
it's for me, it's a home tree, something.
When you because maybe yeah, you're right. Maybe the last year Jean-François made a change. So when you connect inside the GPU and you tape you write PWD, and
Yeah.
this is your current path. So you
Okay.
should take this as your current path.
Okay, but I'm getting home tree
Yes.
slash my.
Yeah. It's just the same. It's just
Yeah.
Okay.
Me, I got this because I was
Yeah.
the session was like created way
Right.
way longer. So yeah, and yeah, so we change.
Can you zoom zoom on your screen? Because I can't see. Or change to bright mode.
Yeah, let's try. Let's try to zoom. Okay,
Yes, it will be better.
lourd, better. So now, yes, you are all seeing this clearly. So now, basically, these are just like a line of like line just to verify that everything is here and everything was found. But basically, the only thing that we need is to define the source that we want to copy, the destination, your destination, the server destination here, so where it will be copied inside the cluster. And this file, I will tell you more about this later. And this file is basically a list of elements that I want to ignore when I copy. And the basically the magic is here. So we just run async with those set of arguments with progress, so you can see the progress of your when you copy. Start to just see at the end what type of like how much did you copy, and you can add, like as I mentioned, the exclude file. It's basically it's the same of like the GitHub ignore. So it's basically an ignore file, but for async. I will show you how you create this after. And you just like add the source D and the destination server and the destination of the new directory. And now what we will do is I will run this inside my workstation and not on the cluster, because I want to be able to copy the code that is inside my PC. So all of this copy, creation of singularity image, creation of singularity image, and transferring the code is made on our PC. It will never be made on the cluster. Okay? Is this clear? Connection is not the connection is scary a bit. So yeah, basically what I do is just run the script, and I hope this will work. I hope only it should work. Asking me my password, so let's see. So everything went well. As you can see, it copied everything, and just give me, as I mentioned, some message how much was copied and the size of the file that was copied. And now if I connect back to the cluster, I will be able to see this. So let's connect back. Yeah, so if now I look, should see something called HPC workshop. Do you see it? Yeah? Cool. So now it's inside, and basically I can do whatever I want inside. I can trade code, can run, I can copy, I can modify. So yeah, basically everything that you can do in your PC, you can do it now inside. So the first step is to copy code. Okay? Then the same procedure will be made with data. So for example, you have like a huge amount of data. Let's say you have like a 2 terabyte of images. You are forced to copy the images to the cluster, and it's basically the same. You go copy data, the same path to your data. You change, for example, if there is some configuration file that you do not want to copy with it, it will be inside, just a text file that will be basically here. And in this rsync ignore, you basically, for example, let's redo the or example, and this one I will make sure to not copy local, for example, and I will just remove this one, the HPC workshop that we just copied. Okay, no, it's not removed.
Sudo.
You do not have access. You do not have sudo right inside the. Is someone remembering the command line to delete folder?
Careful with the command because.
Okay.
rm-rf.
Thanks.
Yeah.
Okay. So it's not present anymore. Just delete it. We good? Do not try to mess with you. So it's really deleted. Now I will copy and I will add the async with I want to ignore what are in the local file. And basically this is a repo. Inside there is just a note, just for the purpose, but it can be anything. It can be images, can be code, can be any type of file. And this one is just a note. So this note is local and don't be copied inside the distant cluster. And what we do now is we run the same script, and you will see that inside the new copied code, the local file will not be present.
Can you open the rsync node.txt? Okay, just local.
Local, that's it. I can also ignore log, also basically because those will be logged inside the cluster. So yeah, we add log also. And now what do I do is, see, I do the same thing. I copy the code. It will ask for the password of the session and just give. And now something very interesting that I will show you now is the fact that we will not directly see with command line what is inside the repo, but with SSHFS, which allow you to have a GUI aspect of your repo. You can directly see, make a connection with your repo that is distant, and have Windows interface that you can directly see what is inside the repo. So let me show to make this more to make this clearer. Yeah. So for my case, it's already on. So since I'm working on something, I do want to mess up things, but I will show the command line. So the command line allow me to see what is inside my session in the cluster. So those are all the repo that I showed you previously. So if I go back and I just all of those are not connected with my PC. We've just it's basically a protocol called SSH that allow you to do this binding with a local repo inside your PC to be able to see what is inside. So as I mentioned, all of this now I do have access directly with the GUI. So and all of this is what I mentioned earlier, basically. And this, what to be able to run this command, I will show you how you need to do this. But basically, what you need is you need to create an empty repo inside your PC. You can like have it in home, in your in desktop, in document, and then you just make sure with the command that I will show you that you just link the cluster and this repo, and it will do a binding, and everything that is in cluster will be able, you will be able to see it and access it through your PC. Okay, and now what we will do is we basically open the script that we the repo that we just copied, and if everything went well, there is no local and there is no log, and as you can see, there is no local and there is no log. Okay? Any questions so far? Everything clear? You should.
No, it's just, to use. I tried using SSH, but.
So now, my friend, I will show you. But so far about like the
No,
how to
about
copy,
the rest, no, it's-
or to like run the code with the SSH file, it's okay. It's clear. So now let's see what is the magic command to do this. Even if I use this like multiple, like thousands of times, I do not remember it like by heart. So what I do most of the time is I type like Control R just to do a reverse search, and what I type is SSHFS, and the command is like this: SSHFS, the actual IP address of the cluster that you need to connect, so your SSH, and then basically the path that you want to connect. So your address, then the path inside that you want to connect. So basically the path that I want to show, that I want to be able to see is data GPU LZ Like I want to see everything. And I want to connect this to the repo that is inside my machine that is called GPU machine. And it is inside the desktop. That's it. And when I'm doing this, I will have the result that I showed you previously, which is this. I will be then able to see all of this.
Can you show the command once again? And the second parameter is the folder where I want to connect locally.
So the parameters are the following. So
Yeah.
the command, your IP address connected to the server. Then you type the actual repo that you want to connect inside. So maybe just one repo can be your root. In my case, it's my root, everything that is inside my session. And I do add the path of where I want to link inside my machine. And this should be an empty repo, basically, that you create. It can be in desktop, it can be in document, everywhere that you want. And if you run this, you should be able to connect.
And once you run it, you just have to run it once. And you have the symbolic link done, and it will stay. Like
It will. It depends. Yeah, it will stay up to a certain amount of time. If you are active on the session, it will stay.
Okay.
If you are inactive for a certain period of time, it will drop the link and it will go away. If you restart your PC, it will go away also.
Okay.
And you can also unbind manually with the unbind. Unmount. Sorry, unmount command. So unmount associated with the path that is in your PC. So home, UN, desktop, GPU machine, in my case.
So
but
you
you
have mounting a partition. So
Yeah. Okay, it is clear. And typically, this is all you develop code inside the cluster. So you have this, and then you have like you come in the morning. You're like, yeah, I need to code today, and basically it's where you code most of the time. You go, and I will show you now. Is very simple. It's like you are in your PC, and you just like you can open a terminal, and you can like call your specific IDE. In my case, IDE, yeah. In my case, it's VS Code, and you can code inside it. Normally, a window will pop up. Maybe it's in my other screen. Probably in my other screen. Yeah, it's my other screen. And then you can see that I do have access to everything that is inside the code. And it's visual. I do not need to type command line inside the cluster to change the code. That's really the beauty of it. Because if we want to change everything from the command line inside the cluster, is very, very difficult. Now, just with this link, you can directly change everything inside the code. Okay?
then you can.
Because right now here is in the cluster.
Yeah. I can, yeah. So let's say I just added this. So I just added I am in the cluster. And now what I want to do is I want maybe to see this script that is changed directly in the cluster. So now we can connect in the cluster and see if this was updated. Okay? So this one is the local one, and this one is the version of the cluster. And if I go, like, yeah, I can do it here. I guess. So we connect. There is some, let's say, time-saving things to do. For example, you can have like a SSH configuration to not type the password every time. But yeah, I'm too lazy to make it. So, but I recommend you to do this. It's just basically having a config file inside SSH with all the credential, and you just need to. Maybe I will show you later. And what we'll do now is we will connect to the SPC, and if we remember correctly, what was changed is
So this can be done with Visual Studio also.
Yeah.
So I think
Yeah.
It's the same.
Again, I changed code, so let's see code. Did you remember what file did I change? Maybe I changed code. Maybe code. So let's see if our message is present now. Yeah. So A and closed. So this was typed inside VS Code, just saved, and all this is synchronized. Okay. So not trying to mess with you and saying things that are not working. Okay. So that's the easiest part of everything. So if it was difficult, so now let's maybe we need to stretch off a bit because it's now the real thing begin. Okay, but it is clear so far. Okay, it's clear. Yeah, something that I briefly mentioned. There is two schools. There is async and SCP for copying, and I do prefer to use async because it's much more efficient for delta of what is changed, what is did not change, because it will be. So, for example, you are developing, and let's say you have just changed some part of the script. Async would just see what change, and it will only copy the amount of change and will not do the full loop and so on. So it's very efficient for if you have big file and there is small changes. So that's the SCP is nice because that's most of the time the first one that you use. But yeah, I recommend using async with the option of async ignore if there is script, typically configuration files, local files, typically that you do an analysis on it to use it, because it allows you to do this. And in SCP, if I'm not saying bullshit, there is not this option. There isn't this option of ignoring specific files. Okay. So let's move on to the next part, which is much more complex. Not try to scare you guys, just like what I'm giving you now is you will be saving like 6 to 8 months of work. It's like 2 hours for 6 to 8 months, so I think it's worth it. So let's go back to the presentation. So yeah, we saw this. So now for us this is very easy. We know this. It's not a problem now. I also showed you this, or to do the SSH in order to have like a GUI access of what is inside the cluster, and to install you need to use this command. I think in Windows there is also, because I'm using it with my PC when I'm doing télétravail, and you just type. I forgot the name exactly of the package, but you just type Windows SSHFS and it will give you the package. Download it, and it's basically there is a small configuration, but it's explained. They explain it in when you download it. And to unmount, as I mentioned, you just type unmount associated with the path of your why it was actually binded. So this is a little bit of repetition, but to make it clear, HPC are very, very powerful, and we want to be able to take advantage of this massive computing, and the thing that we can parallelize scripts with many jobs in many configuration possible, with specific configuration about memory and so on and so forth. And yeah, now comes the actual, let's say, battle between Docker and Singularity. So as I mentioned earlier, is every script and record that will be run inside the cluster is through an image, through a container. And there is today two types. Most popular container is Docker solution, and there is also Singularity is quite popular, but yeah, it's very specific to GPU. And why Slurm do use Apptainer and Singularity. So in the presentation, so what you will see is you will see a lot of time the word Apptainer, but it's basically Singularity. It's the same. Previously, Singularity was an open source project. Then the founding member decided to have a branch that is let's say not that much on open source, and then the project divided, and some people decided to create a new version of Singularity that is open source, and it's called Apptainer, but it's basically the same. Okay, and so what you need to understand is the big message is Singularity is optimized for GPU computing. Docker is not. So in Slurm, we'll be using Singularity, since we want to be able to access multi-GPU and be able to run those all scripts inside this environment. So that's why Slurm is not using Docker. But the idea is pretty much the same. We want an image that we will run our code inside it. That's it. So now, which one of you did install Apptainer or Singularity? Okay. So for those that have their laptop, if you tap Apptainer version, what do you have?
1.4.0.
You have something.
1.4.0.
Perfect. So we have 3 people